Hey guys, welcome back to my channel. Today we're going to be looking at GCSE Chemistry, topic 5, energy changes. So this is all about exothermic and endothermic reactions and about fuel cells, all the exciting stuff. Before we jump in, just a reminder, please let me know if you'd be interested in seeing me go through some exam questions once the chemistry series is complete. And we don't have too many topics left, so that won't be too long. And of course, as usual, I would really appreciate it if you subscribed. Feel free to like the video and of course comment below any questions that you may have. And these will be answered by either myself or your fellow students if they get to it before I do. But let's just dive straight in. So firstly, looking at exothermic and endothermic reactions. So exothermic is when energy transfers to the surroundings when a reaction takes place, so the temperature of the surroundings increases. Examples of this are combustion, many oxidization reactions, and neutralization. So this is when you're doing a reaction in class and you can feel the test tube getting warm. That is an exothermic reaction. Whereas on the other hand, you've got endothermic, so this takes energy from the surroundings. So, it helps if I spell temperature right. So the temperature of the surroundings decreases. An example of this is thermal decomposition. When chemical reactions occur, again, my brain's not working obviously this morning making these, but apologies for any spelling errors. Energy is conserved, so remember that within the reactions no energy can be lost. It's either going in, the only way it's lost really is if it's going into the surroundings. But yeah, basically energy needs to be balanced pretty well. Chemical reactions can only occur when reacting particles collide with each other and with sufficient energy. This is also known as activation energy, so essentially the minimum amount of energy required for a reaction to take place. This is not discussed in this presentation, but this tends to be where the catalyst comes in because it essentially lowers the activation energy required. So the reaction is a lot more efficient and doesn't need as much energy to take place. During a chemical reaction, energy must be supplied to break bonds in the reactants, and energy is released when bonds in the products are formed. If the energy taken in to break these bonds is greater than the energy released when formed, it's an endothermic reaction. But if the energy taken in to break the bonds is less than the energy released when formed, then it's exothermic. Now we have reaction profiles. These are a pretty nifty way to kind of show the exact energy kind of stuff that's going on. So you can see here we've got an exothermic reaction and an endothermic reaction profile. Essentially, the key here is that if the reactant is very much like I just explained, if the reactants on here is higher than products, then it's exothermic. If the reactants is lower than products, then it's endothermic. So these can be used to show the relative energies of reactants and products, activation energy, and overall energy charge. The two different shapes obviously, again, indicate whether it's endothermic or exothermic, but really make sure you fully understand these. Of course, if you do have any questions about them, then feel free to fire away in the comments. But yeah, the key, you really need to be able to understand these because there is the potential for you to be asked to recreate in the exam. Did that just wipe out my whole recording? No, it didn't. Literally ignore me. I would edit that out, but I do not know how to. So anyway, chemical and fuel cells now. So the last slide. This is a super quick section. So cells and batteries. Cells contain chemicals that react to produce electricity. So the voltage produced depends on a variety of different things, but an example of this is a type of electrode and electrolyte used within the cell. A simple cell could be made by connecting two different metals in contact with an electrolyte, and a battery consists of two or more cells connected together in series to provide a greater voltage. The difference between non-rechargeable and rechargeable cells and batteries is that non-rechargeable reactions stop when one of the reactants has been used up, and alkaline batteries are non-rechargeable. But a rechargeable is when the chemical reactions are reversed, when an external electrical current is supplied. Then you've got fuel cells. So these supply Supplied by an external source of fuel and oxygen, as the fuel oxidizes electrochemically within the fuel cell to produce a potential difference. Hydrogen fuel cells offer a potential alternative to rechargeable cells and batteries. You can kind of see how they differ in the table below. So for hydrogen's fuel cells, fuel cells can be used constantly provided fuel keeps being put in. Hydrogen is a gas that needs to be stored at high pressure, so it's harder to transport, and only produces water when burnt, so very eco-friendly. Whereas rechargeable can be recharged by reversing the reaction, so fuel doesn't need to keep being supplied. Hard to dispose of, obviously non-biodegradable, and rechargeable batteries will eventually stop working. They will not last forever. But yeah, that is everything on today's section. Super quick little topic. And yeah, feel free to subscribe, comment below, like, do all the usual shebang. I don't understand how YouTube works. But yeah, I shall see you in my next video.